this is number 4. This time it's asking for the periodic payment amount needed to reach a desired amount. This is kind of like if you think back to the compound interest question where they asked you what is the P to end up with a goal amount, right? To end up with the particular A. A is always standing for the end result that we want to end up with. And A is a future value, right? So this time, since I know A, I don't want to use this first formula. It doesn't make sense because I'm already given A, right? I don't want to use the formula that solves for A because I already know what that is. So I want to use the formula that has A inside of it here. And then what I want to figure out is what is the M? What is the periodic payment that I should make? In this case, yeah, that's what it says. Find the periodic payment. That's the M amount. All right, so I'm using this second formula. Let's just zoom in on that guy. Actually, we'll zoom in on him after we take a note of what our variables are. So here we're at 4. A is $165,000. That's my target goal. I want to end up with that much. So A is equal to 165,000. All right. N is semi-annually. That means N is equal to 2, twice a year, yeah? And R is 2%. Oh man, 2%. That's it. Okay, T is 10 years. So T is 10. Okay, these are all my variables, right? I'm going to plug those guys into this formula because M is the thing that I don't know. If I look at all the things I do know, M is the only one missing, so I must use the one that has M on it. Solving for M. All right, let's plug that thing in. Again, you got to be careful with parentheses here. I'm going to do 165. I'm going to do the numerator in its own set of parentheses. So 165,000 times a new set of parentheses, R over N, 0.02 divided by 2 this time. Close that R over N parentheses and close the numerator parentheses and then divide. Okay, for the denominator, same thing. I need one overall parentheses for everything. And then the next parentheses is for this piece. So parentheses, 1 plus, and this part you don't need it because of the order operations, division is going to happen first anyway. So 0.02 divided by 2. And then raised to the, again, exponents always in parentheses, right? 2 times 10. Close that, subtract 1, and close it. And here's what I get, $7,493.53. Okay, so answer M is equal to 7,493 and 53 cents to the nearest cent. Okay. Find the periodic payment amount needed to reach the desired amount. Okay. That's to the nearest cent. One thing you should be careful of is if I want to make sure that I hit this 165,000, then you want to round up regardless of where your number is. So even if this was 50.521, I would still round up to 53 to make sure that I hit at least this value. Yeah. Okay. So that is the M value. That's the answer for number 4 already. This is how much I should deposit. Semi-annually means this is how much I should deposit at each half year. So twice a year. And assuming it's compounded at that same rate. All right, number 5. A business must raise $70,000 in 5 years. What should the size of the owner's quarterly payment be to a sinking fund? Sinking fund is just another name for annuity, paying 8% compounded quarterly. All right, so let's look at the facts we got. We know that we want A to end up with 70,000. We know that the rate is 8%. Okay, that's nice. No, it's compounded quarterly. Quarterly means 4 times in a year, and we know we need it in 5 years, so T is equal to 5. All right, so let's just plug those values into our formula. Again, this is the formula here for the periodic payment amount. A is 70,000 times 0.08 divided by N is 4. And remember to keep that whole thing in parentheses. I forgot to do at the beginning, so I'm typing it now. And then the denominator in its own set of parentheses, and another one for this guy, 1 plus R over N parentheses. So 1, 2 parentheses, and then 1 plus 0.08 divided by 4. To the, again, in parentheses for the exponent, 4 times 5. And then come back down, subtract 1, close parentheses. So I have 2,880 and 97 cents. So M is equal to 2,880 and 97 cents. Okay, actually, if I want to make sure that I hit 70,000, I should really round up to 98 cents, even though this is a 0 afterwards. It's got this 2 later on. To make if I include it as 97, it's not going to quite reach the 70,000, so I want to round up. But be careful of the wording of the question, right? If it just asks you to round to the nearest cent, then just listen to what their directions say and round to the nearest cent. But if I want to make sure that I'm going to hit at least 70,000, then I would actually go to the next higher number to make sure that I hit that value. And it's actually, well, it should end up as something larger than 70,000 slightly if I pick 98 cents as opposed to 97 cents. But I'd rather have larger than not quite make it there, right? Okay. Number 6, last one. Lottery offers $1 million prize, a $1 million prize to be paid in 20 equal installments of 50,000 at the end of each year. Or 50,000 times 20 is 1 million. Okay, that sounds good. What is the future value of this annuity if the current rate is 5%? All right, so what's going to happen is it's going to be put into an annuity rather than me actually having access to the funds. So what do we know? We don't know A, right? We want to know the end result of the annuity. So A is what we're trying to figure out. That means we're going to be using this formula here, the one that solves for A. What we do know is M. We know M is equal to 50,000. And we know it's at the end of each year, so that means N is equal to 1, once per year. Yeah. T is the number of years, which is 20, because it says 20 equal installments. All right. And then R is the interest rate, 0.05. All right, so I have all my values collected. I'm just going to stick those things into this formula here, the top one, and let's see what pops out. So here we have 50,000, parentheses, 1 plus 0.05 divided by 1 this time, to the in parentheses 1 times T is 20. I don't really need the 1, but I just put it there because it's easier to follow that way. And then I close off the numerator parentheses, and then I divide by the denominator, which is, again, it's in its own set of parentheses, 0.05 divided by 1. Okay, and there it is, 1653297. So I just solved it. It's, what is A? A is 1653297.71 to the nearest cent. What is that? That's 1,653,000. Oh, that sounds better than 1 million. 1,653,297. Sweet. So that's the answer to the last question. That's how much you would end up with if you're that patient to just put all that money into the annuity and not spend it. All right, guys, that is it. Done with this section, with this whole week. So enjoy the rest of your day and the time that you have. Please stay safe and let me know if you guys find any good things to watch in the meantime. Shoots. Bye. See ya.